In this video, we're going to solve a linear inequality both algebraically and graphically. So let's go ahead and get started. We're going to distribute our negative 2, so we'd get 3x minus 4x minus 8 is less than or equal to 2x plus 1. Combining our x's, 3x minus 4x is negative x, is minus 8 is less than or equal to 2x plus 1. Add 8 to both sides, and I would get negative x is less than or equal to 2x plus 9. Subtracting, whoops, I wrote the answer. Subtracting 2x from both sides. You can add and subtract all you want, but it's, let's see, negative x minus 2 more x's is negative 3x, which is less than or equal to 9. Okay, it's right here when I take the action of dividing by a negative. If you multiply or divide by a negative, that is when you need to switch the direction of that inequality symbol. So we would get x is greater than or equal to negative 3. And then in terms of interval notation, we would be here at negative 3, and it's everything greater than negative 3. So I'm going to use a bracket, negative 3 to positive infinity. And those are all the x values that would make that inequality true. So let me show you now how we can just verify and also solve this graphically. So if I go to Desmos, what I'm going to do is take the right hand side and just graph it. So, okay, and now I'm going to do the same thing for the left hand side. I'm just going to create another graph and go ahead and another y equals and graph that one. Okay, good. So now I'm going to go and look and see the point of intersection. So when x has a value of negative 3, that is where these are actually exactly equal to each other. But what the inequality was saying is, when is this red line? Okay, so this one would be the y equals 3x minus 2 times 2x plus 4. When is that one less than, right? Less than or equal to the blue one, and the blue one is the 2x plus 1 graph. So when is the red graph less than the blue graph? Another way of thinking about that is, when is the red graph below the blue graph? And that happens right here. Okay, and then if we go up and look in terms of the x's where that's happening, it's all of these x's right over here. Okay, so if I was going to plug in any x and look to see where, let's say like right here, could go down on the graph, it's equal to, right here, this x, I could go down and the red line is below the green line, or the blue line. Right, so anywhere in that section where those x's show up, if I went and looked at my graphs, the red graph would be below the blue graph. Okay, so that is telling me it's these sections of x's right in here that correspond to the place on the graph where the red line is lower than, less than or equal to the blue line. Okay, so my answer would be, I go to this point up here, the x is negative 3 there. Okay, so it would be from negative 3 to infinity, which is the same that we got solving algebraically.